Let us look into the fourth solid principle, which is the interface segregation principle, or the ISP. So the ISP states that the no code should be forced to depend on the method it doesn't use, which basically means that if you have an interface and let's say that interface has a 10 method, and when you are implementing that particular interface in a class A, and let's say a class A doesn't require all of those the method inside that interface, but you are forced to override all of those methods over there, so that is breaking the rule of the interface segregation. So the ISP will this splits your interface into if you have a large interface, it will help you to split up and to make it a more smaller one and to be more specific one, so the client only have to know the methods that they are interested, or they are going to use it. So if they are not going to use that particular method, so why should they implement it, right? So the interface segregation principle will help us to make our system more decoupled, and thus it will help us to make the refactoring easy, making the change easy, and to redeploy much easier. So just remember that the interface segregation is a principle that will help us to make our interface much more specific and much more smaller. So if you have a very large interface, and that interface is using by a few of your classes, and some classes may be overriding all of those methods, but some class may be just overriding one or two methods from it. So in this case, you have to make your split up your interface and make it a smaller and more specific one. And so let us go into a practical and see how we can implement the interface segregation principle. So here I have created a folder ISP, or the interface segregation, and I have a two folder. One is of the problem and the solution. So let's go inside the problem and create a new file, which is of a main.the file, and I'll just have a main function, and let's have a new file over here and call it, let's say, payment service class, which is of the file. And this should be of the abstract class, because we want to make use of the interface over here. And if we are talking about the interface segregation, so we need to make we need to create an interface over here. So I'll just say payment service interface, and so it should be abstract, not the abstract class. It should be of an abstract class. So inside this, let's have some of the function. We will have an abstract function of a void, and let's say what we can have is pay, so the payment service can make a payment, and we have a void which we can say let's say installment, so pay in the installment, and we have a void, and let's say pay paid cash, right? And let's say I have another function called the void in pay with the wallet, right? And then let's say we have another function void, let's say pay with the what we want to pay is as a crypto, and let's say we pay it by a crypto. And maybe when you have a payment service, you can get some maybe let's say cash, right? Cash back, so cash back. Maybe you get some cash back, or maybe when you do, and you can also do a payment by a coupon. So let's say it should be of PAYP and COUPON, I guess. So let me fix that spelling, and COUPON, coupon. So okay, so we got that. Let's say we have this particular interface which has the option to pay, and then installments, and pay in cash, and then wallet, then we have a crypto, and I guess I can just pay cash on, and the pay is I guess it's quite same. So I guess I can remove this function from here. So otherwise we have ambiguity over here. So pay installment, pay by wallet, pay by crypto, cashback. Maybe you get some cashback when you pay on with the cash, right? And get pay as in pay with the coupon, right? Or maybe you get a coupon code. So we have this interface, and let's say now I have a new class over here. Let's say I want to make a payment with the card payment, card payment, card payment dot file. And now let's say I have a class and card payment, and this will implement our payment service class, the interface that we have created. And now I need to implement all of these 6 missing functionality over here. So if I have this, what I can see over here is you can see that some of the functionality is with the not the card payment, sorry, it should be of the card payment. I'll rename that one to the card payment. And the thing that you can see over here is some of them is I don't need to implement over here. So maybe a card payment, I can have a cashback and installment, and I can make a payment. Let's just say make a pay, or maybe I can get a coupon. That's perfectly fine. But with the card, I pay with the crypto. I'm using a credit card, but let's say credit card or debit card, but I don't have a crypto card over here. I don't have a wallet for that one. So I have to remove this two over here, and you will get an error over there. So that is the problem over here. So when you have this large interface that has a lot of the multiple responsibility over here, it can pay over the installment, wallet. You may have a lot of these. This is just a test case over here, but you may have a lot more of the functionality that you want inside your interface. But when we make use of the interface segregation principle, it's clearly stated that the no class should be forced to implement or to have those methods inside this particular class. You should not force the class to have those methods inside this class if they don't require it. So currently we cannot do anything, and we have to override those two methods over here. And maybe you just have to say that throw an error, or maybe you say that you saw an error dialog box or something over here. You don't need to implement it, right? It's not implementing it. So the solution is the interface segregation principle. So what we'll do is we'll go to the solution and create a new file, and let's call it as a main. Maybe we want to use that main function and the dot, and just main. Let's create a main function, and then I will create a new file. Let's say call it as a payment, payment service. I'll create a new service dot file, and I will create a new file again, crypto. So crypt crypto payment service, right? Sorry, the dot file, and we have the crypto payment service. We have a payment service. What are the other? Maybe we can have one more, which is of the crypto, and okay, I guess that should be fine. And we can also have a new one, and there's wallet payment underscore service dot file. So now what we'll do is we will split up all of our methods. So just copy this and go inside this payment service. Sorry, I need to create a class, right? So let's say I abstract class of the payment, payment service, and then we have this class, and inside this we will have only the wallet is not required, crypto is not required, and then I can just cut this to section from here. So it's not required. I can maybe this particular payment service can do a payment with the pay in cash installment, get a cash back, or pay with the coupon. That's perfectly fine with the payment service. And if I go to the crypto payment over here, so I'll just create a class of the, it should be of the abstract class. So abstract and the class, and I will have CRYP to crypto payment service, and here I will just have pay with the crypto, and maybe you can have a wallet, pay by wallet. So let's say pay by crypto, and then wallet I will put it to somewhere like in the wallet payment. Let's say a class over here, and the wallet payment service, right? And then I'll put that particular function over here. So it should be of the abstract class, not the class. So BSG or basically abstract class. Okay, so now we have a three interface. Now you can see this a payment service, and then we have this wallet service, and then we have a crypto service. So now if I want to have a card payment, so that I'll just copy this card payment over here, and then I can just re-import this payment service from the current package, and now I don't need to have this too over here, right? So now it looks much cleaner and we are more specific, and now our this particular card payment doesn't have to use the unwanted methods, because we are not interested on those methods like the wallet and the crypto payment. We just need to have a cashback, installment, pay, and the coupon. So with the card payment I can have a cashback, installment, and I can just pay with the cash or pay with the coupon. And similarly, if I want to have I can create a new class, and that's, let's say I want to pay using a gpay googlepay.d.file, and with this Google Pay I can just create a class and a gpay or a Google Pay, and then I can implement the wallet service, right? So wallet service payment, and then I can just have those implementation over here. I have one missing, which is a pay using a wallet, right? So you can see that now I can have another one, which is let's say a new file, and call it as a I want to pay using BitPay, right? Let's call it as a BitPay or some Bitcoin Pay or something like that, right? So this is the test class. So I will have a class, let's say a BitPay, and I will implement the function as a crypto payment service, and this will implement the payment like the create missing override and pay with the crypto. That's fine, right? And then you can have even separated this particular the payment service class to just have a payment, and then installment, cashback, and the coupon you can just move into the another interface, or you can just have like the cashback and the coupon to the another one. So it's depend on your requirements. So you can segregate your interface, make it much smaller, and be more specific. So if you just need a pay cash over here with the payment service, you can create a different interface for that one. So let us try to segregate this payment service, and for that I'll just create a new file and call it as a card, let's say card underscore the payment service.d.file, and I'll create a abstract class over here, abstract class of the card payment, let's say a service. And with this card payment service, I will have a function of installment, cashback, and the coupon. So I don't need to have it over here in the payment service, and I'll just go to the card payment service and paste it over here. And then what I need to do is I can just also implement from our payment service over here. So payment payment service. So I guess this is the one. So payment service. So now if I go to the payment wallet payment, card payment, and with this card payment, what I need to do is I need to implement the card payment service, right? So card payment service. And you can see that with this card payment service, I can have all of the functionality like cashback, installment, pay, and the coupon. And for this crypto payment service, it can also implement the payment service, right? So this payment service. And now if I go to the BitPay, which implements the crypto payment service, I need to override the one more method, which is of the pay. So now I can pay crypto or pay. So now I can have a two function, which is specific to the crypto, or I can make a pay or do something like. So this way you can again segregate your interface to much more smaller and to be more specific. So here this has just a payment service which has a function to pay, but we have a card payment service that implements again the payment service, and it has other functionality like installment, cashback, pay, coupon. Similarly, our crypto has the functionality of to pay by crypto, and also it implements the payment service, which means that we can also do a call a function for the make a pay or a pay functionality. So this way you can segregate your interface and make it much more smaller and make it more specific. So if you want to follow your interface segregation principle, this will help us to maintain our code and make it more easier to maintain and refactor and all of those stuff. So hope you guys understand this one, and if you are creating a new project, make sure to follow this interface segregation principle. So let's meet up in the next lecture. Till then, have a great day.